Hello, everyone, and welcome to our latest episode 6 of the Google Lunar XPRIZE Team Hangouts. For those of you who haven't joined us in the past, this is a series of Google Hangouts that are here to help you get to know all of the different teams of people that are working to get us back to the moon and are helping to make that possible. So we're week by week bringing in representatives of each of the teams who are striving to land something on the moon, journey via some means, whether it be hop, fly, crawl, or dance. I think it would be cool if a robot boogied. They need to travel 500 meters and then send a high-definition video back. Whichever team accomplishes that first is going to be the winner of the Google Lunar XPRIZE. Behind this is a whole series of judges and support staff at the XPRIZE Foundation, and together we're working to get the journey back to the moon by everyday people started and hopefully finished sometime in the next year. So with me tonight, I have a pair of men who, unlike me, were around back when the Apollo missions were happening. And tonight we're going to talk a little bit about, well, what it was like the first time and how it is that we're getting ready to return. So with me, I have Derek Weber, who is the Executive Director of Spaceport Association and one of the judges of the Google Lunar XPRIZE. And I also have Robert Brand, who is part of Team Stellar, one of the teams looking to, well, compete for the Google Lunar XPRIZE. And he also works on high-altitude balloons, which are one of the great ways that we're finding to do, well, the type of science we just can't quite do from the surface of the planet. Now, if you have any questions tonight, our questions are there for the asking of our guests. We are using the Q&A app. If you're watching on YouTube, and you should be, I'm not sure how else you'd be watching, just click on the Q&A app, and I will be relaying your questions to our two wonderful guests tonight. Now, as I said earlier, I wasn't actually alive during the original Apollo missions, and in fact I came a year after Apollo-Soyuz. And my first real understanding of just how amazing a thing I had missed came in the 20th anniversary back in 1989. I was competing in the International Science Olympics, and I remember being on a tour bus, and I was in Finland, of all places, on my way back from competing in the Soviet Union, and this had been a big deal in Russia. It had been a big deal in Helsinki, and it's just sort of like, this is just like something NASA did. What's the big deal? And it finally struck me. When did it hit you that you were going to see such an amazing accomplishment and be a part of such an amazing accomplishment during your lifetime? Derek, why don't we start with you?
Okay, well, thank you for inviting me on this hang-up. You have to realize this was something that was happening right throughout the 60s. I was 12 when Sputnik 1 was launched, and that was quite a shocking and extraordinary event. I was 16 when Yuri Gagarin first went into space, and so I was a very impressionable age, and that determined my whole future life, what that was happening. So we actually watched the whole Mercury, Gemini, Apollo thing, and probably Apollo 8 was the one which caught my eye, and I realized at that time, yes, this is going to be possible, even though the people who were involved in it didn't really believe it was possible at the beginning. They didn't know how to do it. When JFK said, we're going to go to the moon, we're going to do it before this decade is out, we'd only had 15 minutes of Alan Shepard's flight at the time. And that was an extraordinarily risky thing to say. But certainly they went ahead and step by step and did it. And I was in the UK, and I could equally follow the Soviet program and the US program, and I was following both. But it wasn't a surprise to me when Apollo 11 came, I was waiting for it and looking forward to it. Every single launch in those days, every Mercury launch, every Gemini launch had something entirely different and new and adventurous and risky in it. And it was a very exciting thing to follow. And there's been nothing like it ever since. And except we're trying to make this competition have a little bit of that attitude to it. But if you want to ask me where was I when it actually happened, I was still in the UK back then. I had just begun work on the British space program. How about that for a laugh? I started in 1966, Blue Streak. Robert will recall Woomer, who we launched from Australia back then, and I was a thermal engineer. So, and in fact, I don't know whether you can see, but this thing I have here is the slide rule, which I used to use to do the orbital calculations, the trajectory calculations. So I see Robert is laughing. That was the technology back then. Slide rules. We eventually had mechanical calculators for crunching the numbers, where if we wanted more decimal places that you could get with the slide rule. And I remember seeing the very first ever electronic calculator, which was, you know, as big as a laptop, and we weren't allowed to touch it. The whole office had to use it. So, and I was just newly married. We had no TV, and so I went to the in-laws to see this thing on a very long night in the UK. Touchdown was at 9 in the evening. The first step was at 4 a.m. in the morning. So my new bride and I were at her parents' house right through the night to see the first step. So that's my recollections.
Now, Robert, you actually had the privilege of being part of what allowed that video that Derek stayed up to watch to happen. And can you share with us your rather remarkable story?
Yes, it was rather a fun time. I was 17 when they landed on the moon, so I was very young. I wasn't expecting to be working on anything to do with Apollo missions, and certainly when Apollo 8 went up, and that too was a signal that something amazing was going to happen, but I had no idea. I was at college and I was on work experience working for Australia's international carrier at the time, OTC, and that company is where NASA decided to put the switching center for the feed from the Parkes radio telescope and also the feed from Honeysuckle Creek, which was one of NASA's deep space networks, where Parkes was an Australian government radio telescope. And but it was bigger, way bigger, twice the diameter. So they thought this would be a good thing to use. And so I just happened to be on work experience in the months leading up to the launch at this very place. And I had a bit of a background by then in wiring and doing all sorts of fun things. And so they got a bit busy. And rather interesting story. The scan converter blew up and all sorts of things just in the weeks prior to the mission. And had to be replaced. There's a bit of a story on my WhatsApp website if anyone wants to read it. That's WOTZUP.com. And there was a big scramble, and that meant it was all hands to the pump, and they grabbed me and started getting me to wire stuff that they would not have otherwise let a 17-year-old wire up. So that was a lot of fun. But I was back at college watching it on a little black and white TV in the corner of the room, along with about 100 other people jammed into the room when it did land. But I did have a little bit of a smug look on my face when I was watching it, I guess. But I must say it's only a minor thing that I did. It was not a big thing. It would be something that anyone else would have done, just putting wires and connectors and all sorts of things together. But it did start me on a track that would eventually lead me to going into the aerospace sector. Just a few years ago, I switched from comms to aerospace, but I did have a part to play in quite a few space missions for the company, including going and being stationed at Parkes for Voyager and Giotto, ESA's Giotto mission to Halley's Comet. So it was a fun time, but it was all comms, and now aerospace is a big part of my life.
Well, the communications is so important and so often under noticed. When you think about the fact that Voyager is now sending back kilobits at best, and from nominally, according to the most recent press release, take your pick, from outside of our solar system, that's all communications technology from before I was born, still working, still transmitting, and still being received by Earth transmitters and received by the receivers rather. And this is the key to getting the information back. Without the comms, the missions are kind of just polluting the solar system with scrap metal. But the sexy part is the launch vehicle at the end of the day. And with Stellar, you're looking at returning to the moon, but you're also looking at doing so much more. Can you give us an overview of what all you're up to today, having come full circle and left and come back to space exploration?
Yes, well, my company decided it was going to go down the path of getting involved in building its own deep space network. I can't say it's been a fast path. It's difficult getting large dishes that are already in place from around the world into the mix and getting them online. But we're working on one in Australia right now, and we're hopeful of getting another one online with the US very shortly. And we have a partner dish in the UK. So we're building a complete 30-metre deep space network for my company, and Stellar is also part of that project. There's a lot to be done, and it means that if you've got 30-metre dishes at your disposal 24 hours a day as the Earth turns, you've got a fairly good bandwidth to play with, and you have priority over other people who might be wanting to book it during that time. NASA's got some competing interests with lots of groups wanting to use the dishes, and I was just looking at something which said that if the New Horizons had a failure of one of the big dishes, I think it was going to take something like 72 days transmitting it just over 1 kilobit per second of data. It was going to take 72 days of using all three of the 70-metre dishes that NASA owns to get the data back from the past. So, you know, you need to have good bandwidth and everything else, but what happens if one of those dishes fails? So they're looking at joining 3 other dishes together. That'd be 3 other missions that would be having to find dishes as well. It gets very awkward, and it'd be good. Stellar would like to have their own network and also some redundancy built into that as well. So we're working hard on that at the moment. And right now I'm doing a lot of work day and night to try and finish a document that's needed, very important document for the comms sector. And you've got lead times of years with some of these dishes and getting them up to scratch. So it is a very difficult project, but I'm loving it.
It's amazing how much doing paperwork is a part of space exploration, and I think that is something they need to do a better job of warning us in school. Thou shalt spend half your career writing paperwork, and you, sir, are a hero to all your engineers who do not have to write the paperwork because you are doing it. It's part of my life as well. Now, Derek, you eventually made your way to the United States. I assume you watched later missions not from your in-laws' television set. What is the journey that you've taken that has brought you to being part of Spaceport Associates and being one of the judges for the Google Lunar XPRIZE?
I've always been a long-range planner, and I got involved in looking at the future markets for space. I was also in the satellite communications sector. I was head of procurement at Inmarsat in London, and so I was buying satellites and then buying the rockets to launch them on. When I came to the States to set up my consulting business, I looked at what these markets were, and I found that they were all going to plateau. I couldn't see where the growth was, except space tourism. It struck me that space tourism, if you and I and Robert are payloads, well, there's a lot more like us and you can start getting economies of scale when you get into, you know, thousands and tens and 20,000. At the moment, there's only 8, on average, 8 launches a year of commercial payloads. So space tourism is the way to enable a whole lot of economies of scale to happen, and I got very much involved in that. And I've spent 10 to 15 years trying to make this happen. It's been a bit frustrating. It's taken so long, but I know it's coming. And I was doing this work when I heard about the Google Lunar XPRIZE. I also wrote a book, and Buzz Aldrin kindly did the introduction for me, so that was rather nice. So I have a nice link into the lunar exploration field. And so I thought this would be a great chance to make my contribution this time around. I mean, I wasn't active as Robert was back then, at least not in the American program. So this is a new chance, and it was very competitive to become a judge. There are 9 of us. We're international, independent judges, and it was quite tough. In fact, I was rejected first time around, and I kept pestering them to please, you know, I think I could be a good judge and so on. And anyway, I got on board, and here I am. And I do think it's very important to continue space exploration. A lot of people put a lot of effort in the 60s and since, and we just need to keep it going. And I think this new commercial paradigm and prizes is a superb way to move forward. And I'm particularly interested in the heritage prizes of the Google Lunar XPRIZE competition. That's something I'm interested in as a judge because I want to encourage people to try, and I know that Team Stellar is trying to land on hopefully not on, but close to a Apollo 12 site, and I want to make sure.
Can you briefly explain what the heritage prizes are for those who might not know?
Yes, the Heritage Prize is if you land your lander near a well-known site, either an Apollo site or any other. There are 70 or more sites on the moon where we've landed stuff, and you can get close enough to take some good high-definition images and send them back. Then there's another $4 million potentially available for that. So, you know, I advocate trying to find Al Shepard's golf ball, you know, and that would be great to a great piece of news. We'll see if he was telling the truth when he said it went for miles and miles and miles.
Well, so the Heritage Prize offers the first opportunity to actually prove things like people think that the flags that were posted have bleached out to being completely white, and we just have a lot of questions. What's been the impact? No pun intended, it just happened that time. What's been the impact of micrometeorites on what's been left behind? And it's only with this high definition imagery that we can't get from orbit, where we're getting 0.5 meter resolution, but that's not good enough. It's only if we land that we can start to answer these questions.
So you're right, there are good scientific and engineering reasons for going to these sites, but also we don't want to ruin that 40 years of history of deposition of lunar dust and radiation effects over the 40-year period. So one of the things we've been working out as judges is, you know, how can you combine these two things? Encourage people to go. Well, there's a $4 million encouragement there, but be careful and don't destroy the heritage or the legacy. I mean, they may want to have a Smithsonian on the moon someday, you know, and you don't want to have all our little Google Lunar rovers going all over the place and wrecking the site. So that's what we're trying to do. We're trying to encourage the progress, but also protect the history.
I now have this mental image of one of the Sony dancing robots, like walking up and picking up the flag and waving it while doing some sort of a flag routine or something. So Robert, with Team Stellar, you're chasing one of these heritage awards. What exactly is it that your team is hoping that you'll be able to do?
Well, that's something that's quite interesting. It's in one of these states of flux where mission profiles determine what happens, and they're changing as they must do as we discover things during our way forward. You know, if weight changes, then you can't change fuel, maybe, so
Yeah.
therefore you have to have less in other areas. So we have to be very careful about what's going on. We have to either get rid of things or have less fuel, and you need fuel for landing, so it's not as if you can deploy a parachute or anything. So we have some rather interesting restrictions compared to coming back to, say, Earth. One of the lovely things about it being fluid is that opportunities come and opportunities go. So things may change and technology changes, and I've just been looking at technology for improved distance with the rover. And in the comm sector, you've got to look at how hills will get in the way of your signal back to your lander if you're communicating via the lander, and how you get around those issues. Because let's say we land 2 kilometres away or 2 miles away or something, we've got a long hike to get there, and I promise you there will be 1 or 2 hills in the way. And
sometimes those hills are called crater walls and things like that, and it gets a bit hairy.
Nice. I was just being nice. I did see some interesting stories and words from some of the Apollo guys driving the rovers and how steep those hills were. But, these things are rather softer than just being crater walls these days, because over time they're not as sharp. They don't have the angular sort of edges that we always thought they would have in the past. And going there has changed our knowledge of the moon greatly, and we hope we'll be able to change it further. But doing some relays and things like that is rather interesting. And how do you do it? How do you put the relays in, and so on? So I'm just working on that paperwork as we speak. But we've done a lot of research, and of course that is some of the interesting things about what we're doing at the moment. Although we were a bit slow in getting off the ground because we started later than the others, we've come a long way. And a lot of the stuff that I'm doing with stratospheric balloons allows for some of that research with comms. But we're also able to research things with small aircraft and a whole lot of things. And my son, who's 12, is part of the team. He's the Australian representative, student representative. But he's helping me with the stratospheric balloons, and he's quite capable. He went to Croatia with me, and he was my right-hand man as far as getting it ready. He can do this all by himself. He has an amateur radio license since age 9, and he's launching all sorts of things. And one of the things that he will be doing in the next 12 months is breaking the sound barrier with a small aircraft. And it will be very interesting, because so far the highest speed has been 400, I think, and 40 miles an hour.
And so just to clarify, this is a drone aircraft. Your 12-year-old son is not going to be flying solo at supersonic speeds.
I was just getting to that. These are very small aircraft. He'll be piloting it from the ground. And we will get one of the universities involved. They've already raised their head to say, yeah, we want to be part of this. So he'll have his own team of PhD students shortly. And he's basically been working on this and piloting small RC aircraft and with point-of-view facilities. But I believe it's possible, and it's part of my company's strategy, as much as of interest to Stella, as to using such experiments for learning how to go transsonic, and potentially in the future with re-entry vehicles and so on. And it will be a very interesting time in the future with all of this. But for Team Stella, yes, we're testing comms, we're testing the relays, we're testing long-distance stuff. And recently we had a stratospheric balloon in Croatia that Jason and I and our CTO, Tim Blacksland from Australia, also went over. And we were having video, high-definition video, being streamed from, I think, over 70 kilometres distance from the balloon. So we're doing all this work because it's what you need to do before you actually make very strong decisions about which technology you use on the moon.
That's entirely true. And what you guys are accomplishing on the side of sorting commercial space, on the side of finding long-term viability plans, in defining the technology, is all complemented by the people who are working to map out the moon in high resolution, which actually includes our citizen scientists over at CosmoQuest and trying to understand craters and what it is that causes them to degrade with time on this surface that has limited atmosphere and no weather or tectonics to speak of. It's all such a complicated problem. And what's amazing is we're figuring it out. Now, there's a lot of people that wish we could be figuring it out faster. And Nancy Graziano asks, do you think Americans will ever experience the urgency for space exploration that we experienced during the Apollo era 60s space race that was obviously fueled by military motivations? Do you think we'll ever be able to, hopefully without the military motivations, get back that sense of urgency? Derek, I'll send this to you first.
Really? Okay. So it's a difficult one. I mean, it was a unique set of circumstances that created Apollo. It was the Cold War. It was all of those astronauts who did all these amazing things were military jet jocks. I talked to Frank Borman once, and he said, I didn't give a damn about the dust on the moon. I just wanted to beat the Soviets, you know. It's just that was what it was about. It was that was their part as military officers of beating the enemy at that time. So I think there's a lot of motivations why people do things, but to do things urgently, which is what the questioner asked, you need a threat of some sort, which tends to be a military thing, or it could be an asteroid heading our way, maybe. Or maybe if China is proposing to do it, that might get America worried and put some urgency into it. But I don't see urgency as part of the equation at the moment. And of course, the very long-term needs for humans in space are to do with extremely long-term risks and threats. And they don't fit easily into an annual budget or even a 4-year senatorial presidential term. So I don't see that it'll never be done the same way, that's for sure.
Robert, you're lucky enough to be in a nation with an economy that seems to be surviving the economic downturn that struck the U.S. and Europe with much better success, in part due to so much exchange with China. Do you see that without military urgency, your nation might be able to step forward and create your own space programs that are perhaps initiated from grassroots?
Well, I'm certainly hoping that things that I'm doing will change that in Australia, but the Australian government continues to tell the people that this is not going to happen, that Australia is too small to be launching vehicles into space. But then I look at New Zealand, and of course there's a company over there that started launching things into orbit with the help of the government. You know, they make it fairly cheap for them to do it. And these are just inconsistencies that I just love to point out, but we've got to get the government on side before we can get these sorts of things happening here, and the government is not currently on side. But
and New Zealand could not be worse placed to try and launch something. Australia's northern coast would be a beautiful place for a commercial facility.
Well, it depends if you're trying to launch into equatorial orbit or otherwise, and so it's ideally placed for some types of orbits. It has ocean to its eastern side, lots of it, so with nothing out there, so it's ideally placed in that regard too. Nonetheless, back on your other question, we have to remember that, yes, the American economy was booming at the time in the lead up to Apollo, and for 10 years or so, there was a lot of money going into it, and at its peak it was 4.5 cents in the tax dollar. And I don't think the American people have an appetite for that sort of price. And of course, these days we'd have to do it with far more safety, because that's what's now demanded.
Yeah.
And we would also have to do it, well, I guess just knowing that things cost way more these days anyway, it's just out of the question. I can't see us going back to the moon. And people have to understand that's always what's limited the US going to the moon right up till now, the cost. It's such a simple thing to say, but people don't believe it because they don't understand how much it really cost the US to do it that time.
And this is where I think so many of us have placed our hope in commercial endeavors such as SpaceX, and I hold out hope that companies like Virgin Galactic are going to allow me to do suborbital from here to Australia, because it just hurts to do it otherwise. And this brings me to a question from Ron Rosano, who says, I'm signed up to fly with Virgin Galactic and hope to get to space in 2016 or so. What kinds of things do you think we Virgin Galactic passengers can do to inspire students to be interested in science, technology, engineering, and math? Derek, I'll throw this one to you.
Okay. Well, first of all, congratulations on getting on the list. I know there's about 500 people lined up there, and I think your expectation of 2016 is probably reasonable. Although I've been waiting since 2004 for this to happen. But I'm glad, and I've noticed, I've been to some events where these Virgin Galactic new astronauts are all assembled, and they have done some great work as a group, and they have tried to help schools and get people aware of what the possibilities are. So I know that they're a force to be reckoned with. I mean, they're all very wealthy and a lot younger than I would have expected, actually, for millionaires to be. I don't know how they got to be millionaires at the
It's the .coms.
Yes, but yeah, I just encourage them to keep on doing what they're doing. Is sort of spread the word that what they're going to do and what they're going to see. They're going to see that the thin atmosphere of the Earth, the curvature of the Earth, and the fact that once you're up there, we're all in the same boat, basically.
Yeah, as I'm going to take the host prerogative to sort of throw an answer at this one. I work as a STEM educator in addition to being a researcher, and the one thing that we need the help with most is people who are willing to not just throw their time and their social networks at supporting us, but for the cost of 4 of you to go to space, you could fund a science education team that does vast amounts of professional development. Due to budget cuts, NASA has been drastically cutting the money available for science education. The National Science Foundation has, by necessity and congressional influence, been switching so that instead of funding science education programs, it's funding science education research. We need money just to sometimes print things to give teachers. And if there could be a Virgin Galactic foundation of some sort that helped inspire kids by just providing seed funding to do things as simple as get Lego Mindstorms out there, or to do stratospheric balloon launches, it would get science into kids' hands instead of just being something they watch on the internet. And that would be awesome. So that's just my 2 cents. Stepping down off of my soapbox of being a science educator. So as I said, my personal dream for the future is a suborbital flight to Australia, because really it is a long pair of flights otherwise. What are your personal hopes for things that you'll experience as we move into a more commercial space future? Robert?
Yes. I'm not sure I actually want to go and get on any of the earlier flights myself. I like a little bit more, let's see the statistics on this.
I'm young enough I can wait.
Hey, so am I.
Yes.
I certainly find it interesting to know that in hindsight they were thinking that the early shuttle flights were about, I think, 1 in 9 or something chance of not making it back, and they improved that. And of course, after each of the disasters, they went into a lot of effort to improve it further as they found more and more things wrong. So I'll let those first people work on how it's going to go. I look forward to great success, but I'm not sure I actually want to sit on the back of it. Now, I'm someone who has done a lot of dangerous sports in my time. I may not look it, but jumping off cliffs and you name it,
I
putting
jump
on.
horses. I get it.
Yeah, but I was doing this stuff every weekend, diving with great whites, no cages, and all sorts of things. You name it. But bottom line is, there's a lot of things to happen. I mean, even with tourist flights, you're going to see things such as people jumping out in space and coming back down, much like that guy did with the Red Bull jump. And he had trouble with spinning, and I'll fix all that, and I'll work out ways of doing it. We'll see new sports adventures coming our way with things like that. There's been a couple of companies already starting to work on this sort of thing. So the future for tourism is great. We're looking at round the moon trips. We're looking at a whole lot of different tourism sort of exercises, and they'll sort of be more inspiring for just being there. How you inspire kids to do stuff, I think you've got to let them see that they can get involved. If you just want to say, how do you inspire someone by me going up on a tourist flight, well, that's not going to be too inspiring. But if you say, well, come out and let's launch a balloon and track it and recover it, and you can be part of the group tracking it and so on, you do change the whole way things work and the opportunities. And that's part of why Jason and I went to Croatia, because Team Stellar was enabling kids to put their payloads on our balloon, and we'd launched it and recover it. We had a lot of interesting problems doing that, but there were landmines to consider where it landed. There were very tight borders, and we didn't want to go over into the bordering countries with things that looked like death ray machines and all sorts of things dangling off our balloon. So we had to be very, very careful and work very steadily towards exactly to bring it down where we wanted to. But that's inspirational in my books. That's where people can track what's happening. They can see on our video what's going on, and they can even join in and provide the experiment. So I think the future for how we engage with aerospace and that is great. I mean, being part of, maybe we can put a reward down that some people get to steer our rover while it's on the moon and get things inspired. But personally, I'm working on an art and a sort of project which will actually take art to the moon. And
that's excellent.
we have some astronauts that will contribute some small paintings that will go on a one-way trip. But better still, we hope to take children's pictures digitized to the moon, and that easy. I mean, lots of people take names and things onto the moon, but we hope to actually, in the quiet times, with our bandwidth, actually bring them back from the moon and send them back to the kids.
That's excellent. Well, Felix Baumgartner's jump was certainly something that caught a great deal of, in some cases, slightly horrified and oh my gosh, is he going to die type of attention. The sending of art is something that's so captivating. There's Daniela De Paula's Moon Bounce program today. There was all over the internet pictures of I think it's actually a student who was launching plants on high atmospheric balloons to see how they fell apart as they hit close to vacuum, and it was just stunningly beautiful. And also allows you to start to answer the questions: what sort of veg will survive if you decompress? There's so much room to explore and inspire and engage. And we've run over time, and this has been an absolutely fabulous discussion. And I think I'm going to ask both of you to end it with an extension of where this question that I rudely didn't let Derek answer. With what message would you leave for the future? The jet cars didn't exactly happen for my generation, but what can you hope for the next generation coming up? And hopefully in your lifetime see that next generation achieve it. Derek?
Well, I do agree with Robert that the space tourism is going to happen, and it's going to take many different forms. And you may be able to go to a spaceport and get a standby ticket, you know, when this thing gets going. So that's something worth following and getting involved with. What I personally want to do is be around to give the awards for the successful Google Lunar XPRIZE contestants, because if they actually do achieve what they have to do to win this award, that will be astonishing. Because most of these are teams of 20 guys working in a garage, whereas back in the 60s it was 400,000 Americans using 5.5% of GDP to do it. So it is a paradigm shift in terms of the ways of doing business. So I'm very interested in commercial space. I think what I'd love to see, if I still can in my life, is when we start switching the equation so that space is seen as a revenue-generating thing, not a sink for money. I think most Americans just think it costs $17 billion a year for NASA, and it's a one-way flow of money. I think it's you know, with asteroid mining and all these kind of things, there's a commercial future in space, even beyond space tourism, which will. I'd like to see the beginnings of that happening. There will come a time when it switches, and it's not a net cost but a net benefit financially.
Robert?
Yes, I agree. Asteroid mining is something that I'm personally involved with as far as my direction of my own company is concerned, and being a taxi to bring back materials from survey vessels. But one thing that's really important is to understand how that will change the world's economies too, because whoever brings that back will have access to all sorts of new materials that will then be able to be used for medicines, for construction and all sorts of things. And it may make the rich richer and the poor poorer, which is a bit of a worry.
Yeah.
But it's one of those things that will change everything, and hopefully diamonds will be rubbish eventually. I know you girls love them, but they're really not as worthwhile as people think they are.
Hey, I'm just wearing merino glass, so.
But you know, they're just an everyday hard mineral of some sort. Not mineral, but yes, it's one of those lovely things that marketing has pushed through the roof, and rubbish pink diamonds are now worth more than the pure ones. Again, marketing, but we have to look at how the world changes with all of this, and yes, minerals will change. Maybe gold will become a thing that's so common that it's worthless as a commodity around the world as well. It will change things, and I do look forward to seeing how that happens. And of course, hopefully we'll be able to redistribute the wealth from some of this to other countries, and not be greedy about it. And I'm looking forward to just seeing what it really can do, especially for medicine.
It's going to be an amazing next few years with everything. It's the new age of Kitty Hawk, except instead of barnstorming, we're now storming the stars, and it's pretty awesome. It's been fabulous talking with the both of you. Time has flown, and I hope that we see many of the things you wish for become realities. For those of you out there watching, thank you so much for joining us. I've noticed that the number of viewers has just sat there steady as you've stayed throughout the show. If you want to learn more about the Google Lunar XPRIZE, just go ahead, visit the website, follow us on Google+, and at GLXP on Twitter. And if you'd like to be part of helping to explore the moon, join cosmoquest.org, where we're working to map out the moon in hopes that tomorrow's future explorers will know where those craters are so they don't land on them, unless they want to. Thank you all so much. Thank you, Derek. Thank you, Robert. This has been an amazing evening, And stay tuned on Google Plus to learn more about the next time we're having one of these Google Lunar Plus team hangouts. Thank you, and
Thank
have a
you.
great evening.
Thank you, Pamela.
Thank you.
Of just how amazing a thing I had missed came in the 20th anniversary back in 1989. I was competing in the International Science Olympics, and I remember being on a tour bus, and I was in Finland, of all places, on my way back from competing in the Soviet Union, and this had been a big deal in Russia. It had been a big deal in Helsinki, and it's just sort of like, this is just like something NASA did. What's the big deal? And it finally struck me. When did it hit you that you were going to see such an amazing accomplishment and be a part of such an amazing accomplishment during your lifetime? Derek, why don't we start with you?
Okay, well, thank you for inviting me on this hang-up. You have to realize this was something that was happening right throughout the 60s. I was 12 when Sputnik 1 was launched, and that was quite a shocking and extraordinary event. I was 16 when Yuri Gagarin first went into space, and so I was a very impressionable age, and that determined my whole future life, what that was happening. So we actually watched the whole Mercury, Gemini, Apollo thing, and probably Apollo 8 was the one which caught my eye, and I realized at that time, yes, this is going to be possible, even though the people who were involved in it didn't really believe it was possible at the beginning. They didn't know how to do it. When JFK said, we're going to go to the moon, we're going to do it
Hello, everyone, and welcome to our latest episode 6 of the Google Lunar XPRIZE Team Hangouts. For those of you who haven't joined us in the past, this is a series of Google Hangouts that are here to help you get to know all of the different teams of people that are working to get us back to the moon and are helping to make that possible. So we're week by week bringing in representatives of each of the teams who are striving to land something on the moon, journey via some means, whether it be hop, fly, crawl, or dance. I think it would be cool if a robot boogied. They need to travel 500 meters and then send a high-definition video back. Whichever team accomplishes that first is going to be the winner of the Google Lunar XPRIZE. Behind this is a whole compete for the Google Lunar XPRIZE, and he also works on high-altitude balloons, which are one of the great ways that we're finding to do, well, the type of science we just can't quite do from the surface of the planet. Now, if you have any questions tonight, our questions are there for the asking of our guests. We are using the Q&A app. If you're watching on YouTube, and you should be, I'm not sure how else you'd be watching, just click on the Q&A app, and I will be relaying your questions to our two wonderful guests tonight. Now, as I said earlier, I wasn't actually alive during the original Apollo missions, and in fact, I came a year after Apollo-Soyuz. And my first real understanding of a series of judges and support staff at the XPRIZE Foundation, and together we're working to get the journey back to the moon by everyday people started and hopefully finished sometime in the next year. So with me tonight, I have a pair of men who, unlike me, were around back when the Apollo missions were happening. And tonight we're going to talk a little bit about, well, what it was like the first time and how it is that we're getting ready to return. So with me, I have Derek Weber, who is the Executive Director of Spaceport Association and one of the judges of the Google Lunar XPRIZE. And I also have Robert Brand, who is part of Team Stellar, one of the teams looking to